Hi everyone. So I actually wanted to train to improve my coding and all. So I was doing some problems. Currently I am about 1850 rating, 1860. So I wanted to see how my thought process works when I solve a problem. A little bit easier than my difficulty. So what I'll do, I'll try to pick a random problem from 1700 rating, which I haven't seen yet, and we'll try to think, uh, explain my thought process, and then code also. If everything happens to be fine, I'll put it on YouTube. If you're watching this, then you probably everything went fine. I've seen the STL problem. It was a very implementation based problem, so I won't do it. I'll try to do some problems which are not so implementation heavy, but would have something very interesting behind them going on. So maybe average score alpha looks like nice, nice. Looks like a nice problem. So okay, it is a C problem of a Div 1 kind of contest. It should be fine. After the educational reform, polygon. Mm, an average score. um, Without rounding up or down. X1, X2 को maximize करना, where X1 is the average score in first and X2 is the average score in the second. So there is, we have been given with some n, then we have given some a and b such that their sum is n. Third, we are given some 5 integers, which are the marks. What we are supposed to do, we need to print, we need to assign them to a set 1 or set 2, such that if there are several possible solutions, then print the sequence. Okay, okay, okay. What is the maximizing criteria? So maximize x1 and x2. So I think we need to divide them in two sets and we need to just maximize something. Uh, so in the first case, I think the answer will be 4 plus 4.5, which is 8.5. And then we also should be doing something known as lexicographically. Looks like a very no, n is very high. That is fine, right? So what if n is very high? Just need to assign. What is a and b, by the way? Oh, we need to assign them to a set of these numbers only. Okay. So I think that is uh, then only why 5 people. Huh, that is fine, but their TI is 5. Okay, that is cool. That means we have been given n numbers. We need to divide in two sets, S1 and S2, and we aim to maximize S1 and S2's average. There is a hint given in the problem. We should be solving it in n log n or n. There is a hint given in the problem that the value of TIs is less than 5. This is particularly a very nice hint, but I think it should be solvable even if TI were allowed to go higher values. So we need to maximize these two things. If there would have been a one set, then we can't do anything. But let's say there are two sets, then what should be the criteria? There are some small numbers and some high numbers. There are obviously two things. The very first thing is we can always put the maximum guys in one and lowest guys in second, but that won't be much feasible, right? Uh, so idea is I don't think everyone will be same. Hmm. Huh. So let's say we have a set in which every element is small, in which, let's say, these, okay, I'll try to put it here. Pen. अरे कोडिंग का है sketch.il लेते हैं. Looks like some greedy should be there. Let's see. तो so let's see. Let's say we have n numbers, and the very first set A, I'll try to put all the small guys here, and in the B, I'll try to put the remaining. So I'll sort the array. We'll sort the array, so forth, and we'll pick the smallest A guys from this set and another remaining B sets in the second array. So now our so what will be the answer? Answer should be equal to x x1 till xa by a plus xa plus 1 summation over xn. This is our b. This will give you some value y1, let's say. Let's try to shift one value from here to here. Okay, when I'll do this x a plus 1 and put it back here, then the difference of them by a will get increased here. If I'll try to put it here, set that equal to y. So idea is to shift one value from here to here. What is y and what is y2? Let's try to find the difference between y1 and y2. Mostly everything got cancelled out. Just uh, most of the part got cancelled out. The thing that got remained, we'll try to first write xa1 plus a plus xa plus b, and here it was opposite. It was xa over a minus xa plus 1 over b. So I think their difference is equal to since these guys are positive, so we can take this. This is always positive, right? So it turns out this is equal to matlab b minus a. So I think this is mostly positive. So I think we should assign the bigger values to a smaller set. Yeah, that is the only scenario I can see. So yes, this is the case. So yes, so I think in general the answer is like this. So we should be outputting, so whatever is higher, let's say if it is uh, so if a is higher, for simplicity let's assume a is higher, else we'll flip the answer. If a is higher, then we will try to put max b elements in 2. That's it. That is the solution, and the rest 2 ones. So here in this case, we know that this is lower, so we'll try to put the higher elements. We'll try to put higher elements here. So basically, we need to. Okay, I'll try to rephrase what I was saying. I think that what should we be doing is there are two sets. One would be higher than other. Both could be equal. If both are equal, then let's try to solve that for later. But if they are unequal, then one is higher and one is lower. The set which will have lower number of elements should contain the high elements, should contain the maximum elements. So here it is the size, it is a set with size 2, and it should contain a 5 and a 4. We should be choosing this 5 at this place and a 2 here to make it lesser or really smaller. So I think that is the only thing that is remaining now. Okay, how can we solve this? Basically what we can do, so we need to assign this two, we need to assign all the ones from the left and from the right. What we can do is we can just sort the array. We can take the minimum of these guys and then we will pick the rightmost guys. After picking the rightmost heavy guys, we kind of know that in our answer these numbers should be present, but there can be multiple of them. So now we need to just pick those values. How can we pick these values very efficiently? Okay, so idea is like this. We will try to pick. We'll try to pick the. We'll try to greedily assign the values for the ones because we can just greedily assign. If not, we'll assign a two, and then remaining will be one. So instead, we'll try to find out all the values such that they belong to the first set. If this is higher than all the smaller elements, if this is lower than all the higher elements. So now we kind of know that these were the elements that should have belonged here, and then we will do this. Let's try to code this society and see. Okay, I think it was easy. What happened? Sorry. So we have taken N, we'll take A and B, we'll take N values. So as I was saying, I think this didn't have any role in forming any proof or so that is fine, but sometimes they intentionally put these values. Okay, now let's solve for a. If a is less than b, then that kind of means that we should be picking the higher values. Let's sort this t. I think we better to sort this t. After sorting this t, if so 1 goes to lower elements, so we should be 1 goes to higher bigger elements. Since a is less than, then we should be having high elements to the smaller set, and that will be a, else we'll pick from the largest. So what we can do here in this scenario, just reverse our t plus 1 plus t plus 1 plus n. Now we'll pick the starting a elements and then the rest of them will be here. So that is should be again straightforward. We'll put here a multi-set for that. We will put any square inside to your that. So now these are the values that we will be giving our answer. And these should be the values in which we should be putting our 1, and then we'll else we'll try to put it as 2. But there is one problem. Since we have changed the order, we need to maintain something known as order to establish. We have sorted this thing. So we'll create this guy. Then for every element we'll try to assign some values to it. It will be better if we create a map. We'll save some coding time. That's it. And we can just do like these many occurrences of element we should be there. And then we'll be like if there are some values which I can create, then definitely I will take those values and will output as 1. Else we can't tail do set 2. Then I think we can just output here. There is no need to create a loop or so. Let's try to submit it. Okay. If I see the mistake. First solution, I think it is correct. What about the second one? Okay, this is wrong. 1, 2, 1, 2. So they are saying my solution is saying it is 1, 2, 1, 2. That means I'm putting 3 and a 4 in the first set, but they are putting 3 and a 5 in the second set. Okay. What about this one? That should not be there. We have done something wrong. 2, 2, 2, 1, 2, 2. This is fine, but this is wrong. So their average score that they will get is 4 plus 4.5, which is 8.5. But I'll get something known as 5 plus 3.5, which is also 8.5. So we both have same values, but there is more lexicographically smaller. So I believe, yeah, that can happen actually, because there there are many ways to achieve. There are actually many ways by which you kind of so basically it is the sum of the set that matters and not the exact element. So for example, in my case, uh, they are taking their sum as 8 and another one as 9, but in my example I'm taking it as 7 and 10. Kind of both works, but somehow we are again restricted in this area. I kind of feel that this might be the place where I think this thing would come into the picture. So this in a way suggests that the summation of all the elements will be less than 5 and then 5. Hence we kind of some kind of have a subset dp. So at every element let dp of I be the running average such that let dpi comma 1 be the running average that I belongs to set 1. But then we should also be keeping track of how many pairs we are putting at least at one set, which we can't do. So DB is not feasible. Like, we can keep track of how many A ones we have put it, but that won't be cool. So in short, that's what we mean by DB. How can we solve it? For the answer, there has to be some easy way. Hmm. We can. Hmm. Okay. Hmm. Ideally, there are multiple ways that you can achieve the same value, but I felt there is only one way of assigning those. Like, eventually, the answer, what to me it looked like the answer should be one. But there exists actually two different ways of putting numbers such that their their answer is different. So, okay, I think uh, there are other mathematical concepts also. Other concepts are like this. We know the average, so we know the sum, we know the average of first guy, that be a1. We can find with the size a, we kind of can find the average of v, that will be s minus a1 into a by b, right? So only having one average, we kind of can find everything. So also I can say we need to maximize this a1. So there are many averages that goes with this. No, there cannot be some numbers. Like, that will defy the purpose. Ideally, it depends on A1, and this is the answer. So eventually it depends on which one is higher. If it is B or if it is A. And depending on that, your values will change. So in their case, their answer is 4 and my answer is 3.5. Uh, this suggests their answer is independent of the another answer. That can't happen, right? See, my assignment means 3 and 4 in one set and 5 from another set, which suggests a 5 and 3.5 and 8.5. If they are saying 3 and 5 in one, 4 and 5 in another, which suggests a 4.5 here and 5, 8.5. That is bullshit. There is something wrong with it. Their sum is 17 minus a1 into a. What is a1? 3.5 into 7, 10. Hmm. I think in this case, since both are equal, cannot do anything. We need to put a higher a to a b. I think my answer is pretty much equal if a1 is not equal to a2, if a is not equal to b, but mostly because in that case, answer, no matter which sets you pick, I think answer is agnostic of the elements you pick. Answer will eventually be the same. So answer is all the ones and all the twos, but I think that's what it is. But in other cases, I think my answer will work because in those cases it depends on the first average. So maybe we can do something like this. This is my solution. This should work. I hope, I think this is correct. Everything looks good. Let's see if it will work or not. Looks like it worked. Not sure. Uh, okay, so I think solution is correct. So let's look at what we did here. So initially, I think started off with having an observation that with some observations I started. The very first observation I came that was correct was कि we have to divide it into two sets. If one is smaller and one is larger, then smaller set should contain the higher elements, and the larger set should contain the smaller elements. That was the very first thing that you can prove mathematically. I have proved it alongside, and this was the first thing that came to my mind. And then there was this test case I was reading wrong because when two sets are equal, it actually doesn't matter because their average will be constant throughout no matter what how you assign these things. Okay. Thank you.